Okay, in the next 10 minutes, I will explain a little bit about the topics that we will cover after the first midterm exam. Okay, the next topic is about frame and machine. Yeah, frame and machine. It is slightly different of what you have learned before about truss. In the truss, all the member is two force member, but in the frame, okay, not necessarily all the member is two force member. So at least one of the member is multi-force member. If one of the member is multi-force member, we cannot call the system truss anymore. So it will become either frame or machine. Okay, actually the way to solve it is just the same, but frame is more likely just a structure which not which cannot move by itself. Then machine is structure which can move by itself. Okay, so these are the difference between frame and machine. Okay, frames is a structure which are designed to support applied loads, and the position is usually fixed like this. We call it as a frame. But machine, okay, like this, okay, it's a structure which contain moving parts and are designed to transmit input force into couples or output forces, like this. Okay, that's the difference between frame and machine, and you don't have to know exactly how to solve each of those, because both have the same way to solve. You can solve it using the same methodology like that. Okay, so it's a frame, it's a machine. The most important part there, the most important thing there is not necessarily all the member there is two force members. So in a frame or machine, at least one of the member is multi-force member. Jadi saya coba jelaskan dalam bahasa Indonesia. Frame dan mesin itu tuh mirip-mirip ya. Frame itu struktur yang didesain untuk mensupport beban, dan biasanya fix, posisinya fix. Lalu mesin itu adalah struktur yang ada parts-parts yang bergerak dan didesain untuk mentransmisikan gaya input menjadi couple atau gaya output, seperti itu. Nah, kita tidak perlu tahu bagaimana cara menyelesaikannya satu persatu, karena keduanya itu sama cara penyelesaian. Ya, cara penyelesaian itu sama. Ya, analisis prosedurnya seperti ini. Tetapi ini kita akan bahas lebih detail minggu depan. Okay, so this is the analysis procedure, but we will discuss this further next week. Okay. So the first thing that you're supposed to do is to identify the two force member, then isolate each multi-force member, to draw the free body diagram of the multi-force member. Okay, then try to calculate the unknown force. Okay, calculate the number of the unknown force, calculate the number of available equation. If it match, then you can solve using the equilibrium equation. That's it. But if it's not matched, you have to find the other equation. Okay. So this one is the simplest case that I can give it to you guys. This is a frame machine. This is a frame problem. This one is not truss problem anymore. Why? Because member BC over here is not two force member anymore. It's a multi-force member because it has force 2000 Newton in the middle of the member. Remember, the definition of two force member the forces can only be applied at both ends only. That's two force member. Okay, if the forces is not just applied at both ends, then it become multi-force member. So this is the case where we have multi-force member. In this case, we call this as a frame instead of calling it as a truss, because member BC is multi-force member. But when we take a look at member AB, you can see that the force is only given at A and B, which is both ends of it, which means member AB here is two force member. So member AB is two force member, but member BC is not two force member. So how can we solve this? As usual, if we know that a member is two force member, we can just replace the member into one force in the same line of action. So basically, we can just draw this particular free body diagram into like this. If we want to draw the member BC, okay, this is member BC. We know that there is in the middle, we have 200 Newton in the middle. And we know that at B, okay, at B, there is a force from member AB. And the force is in that direction. So this one is FAB. What else that we have there? At point C. At point C here, there is a pin joint. If it's a pin joint, okay, if there is a pin joint, then of course we have to draw it like this. CY, CX. So this is the final free body diagram that we're supposed to solve. Okay, remember that member BC is not two force member. Okay, and based on the analysis procedure here, we know that the member BC, we know that we only need to solve the non-two force member. Okay, the multi-force member. So we just need to draw the free body diagram of member BC. So it's like this, right? This is the free body diagram that I drew just now. Okay, we have three equations: sigma fx equal to 0, sigma fy equal to 0, and sigma moment equal to 0. And we have three unknowns: cx, cy, and fab. The number of equations match with the number of unknowns, so we can solve that. Remember, when we take a look at this, the number of equations and the number of unknowns is supposed to be matched in order for us to be able to solve this. So we will be able to solve it using these three equations to solve for cx, cy, and fab. And this is the results. Okay. I will just give you like a intro only about the frame, because I will discuss this a little further after the exam. So on the in the class of on Thursday in our class. So this is another example of a frame. You can see, right? Member AD there is actually one full beam. Member AD there is one full beam. So actually, this the connection there, it's happening on the member AD. So you can see that member AD is a long beam. It's not separated into two like this. It's not, but it's a long beam. So basically, you can see that member AD have a force in the middle of the member. Because of that, member AD is not two force member, it's multi-force member. So it's a frame case. It's a frame case. And beside that, member CB, BC, member BC, the force is only happening at both ends. The force is only happening at both ends. Okay. That's why member BC is 2 force member. So if we can replace, as usual, we can replace 2 force member with only 1 force in the same line of action, like that. So later, this particular member, we can replace it with just 1 force in the same line of action, like this. Okay, this is another case of a frame. Okay, this one is frame as well. This one is a machine. So next week I will discuss a little further about frame and machine. But for today, I will just give like a short intro on the frame and machine. Okay. Please frequently check your EduNext, because the announcement of the exam I will give it via EduNext. Oke, jadi tolong kalian cek secara rutin EduNext ya, karena pengumuman terkait dengan exam akan saya berikan di EduNext. Oke, ada yang ingin bertanya? Is there any question before I wrap up the class? No? Okay then. In that case, I think that's all for today. Okay. Thank you very much for listening. Please try to prepare your best. Please try to prepare for the exam. So as I told you, the exam will be held on Tuesday next week, 8 March at 7 p.m. at night. Ya, perlu diingat ujian UTS 1 ya, UTS 1 statika akan diadakan hari Selasa minggu depan tanggal 8 Maret ya. Selasa minggu depan tanggal 8 Maret jam 7 malam. And most of the time I believe you have to be there at least at 6:30 p.m. Oke, jadi kalian harus ada di ruangan Zoom-nya sebelum jam 6.30. Sebelum jam 6.30 malam. Oke. Siapkan kertas A4 baru, siapkan alat tulis ballpoint ya. Okay, you have to prepare the A4 papers, the new A4 papers, and the ballpoint as well. Okay, and calculators, remember, dan juga kalkulator ya. Remember that you cannot use your phone as your calculator, you cannot use your computer as your calculator. Jadi kalian tidak boleh pakai komputer sebagai kalkulator, tidak boleh pakai HP sebagai kalkulator. Harus menggunakan kalkulator benar. Okay. I think that's all for today. Thank you very much for listening. See you guys on Tuesday actually. Okay, in the exam room. Okay, see you. Bye.
Thank you, sir.
Thank you, sir.
Sir.